Welcome to today's episode, this fabulous episode of Chemistry with Mrs. Flint at Home. Today we're going to be talking about percent composition. This is not a difficult concept if you've been doing percents ever since you've been in grade school and old enough to calculate the percent of a grade. Remember that a percent is just a part divided by the whole multiplied by 100. So when we're talking about compounds, you already know how to get the molar mass. The molar mass, basically what you're doing is you're adding up the weight of the atoms. So for this one right here, we've got NaCl. There's our sodium. There's our chlorine. We add them together and we're going to get the atomic mass, which if you add these two numbers together, you're going to get 58.44 grams per mole. Grams per mole. And this is, of course, the molar mass. So we take the atomic masses, add them together, and it's going to give us the molar mass. The formula for any kind of percent composition is going to be the mass of the element divided by the total mass of the compound times 100. So in this case, we've got sodium. So sodium is the part, and we're going to put it over the top, 22.99 divided by the whole. This was our whole. So our weight of our molar mass is going to go here, 58.44. Now we're going to multiply that by 100, and you'll get 39.34%. We're going to stay with our significant figure rules. There's 4 significant figures in all these numbers, so it's pretty easy to know that you're going to need 4 significant figures in your answer. Now for the chlorine, our part was this. So our chlorine's going to go here, divided by our whole, which was the total weight, or the molar mass, times 100. And when you put that in the calculator, it's going to be 60.66. Now when you add these together, of course it should add up to be 100%. Now, when we're thinking about percent composition, a sodium or a salt crystal, which is basically NaCl, will always be the same percent by mass, no matter if you've got a grain of salt or a truckload of salt. NaCl will always be 39.34% sodium, and it'll be 60.66% chlorine. It doesn't matter the size of the amount, that percent's going to stay the same. Let's try another one. So we've got a new compound here, Al2O3, aluminum oxide. So in this compound, as you already know because you know how to calculate these, we've got 2 aluminum atoms. We've got 3 oxygen atoms. So we need to find out the weights of these and figure out what our total mass is. So we have 2 aluminum. Each of them weighs 26.98. The 3 oxygen is 16.00. Multiply those together and you're going to get 53.96. And this one's going to be 48.00. Add them together to get a molar mass of 101. Oops, I'm going to write that a little better so you can see it better. 101.96 grams per mole. Grams per mole. Molar mass is always grams per mole. So now we're ready to do our final calculations for the percents. So the total amount of aluminum is going to be this number right here. Whoop, hang on, back up, I grabbed the wrong number. Total amount of aluminum is this number right here. So that's our part. We had 2 atoms of aluminum. They totaled 53.96. And then you're going to divide it by the whole, which was the molar mass. 101.96 put that in the calculator, and we've got 52.92 is going to be the percent of aluminum. Remember, you're going with your lowest number of significant figures, so this number right here is going to set your significant figures, because that's got 4 significant figures where your molar mass had 5. Let's do the other one, shall we? The total amount of oxygen, you can already see there's an arrow printed right there, is 48.00. Our total amount for the compound was the molar mass of 101.96. We put that in, divide those, multiply by 100, and the percent of oxygen is going to be 47.08%. There we go. Now I'm going to work one out for you right here. Not a lot of space for these. I wish I had made this worksheet a little bit smaller font, and just so that things would fit a little bit more. So it says calculate the percent composition of silver hydroxide. Now you're going to need the formula for silver hydroxide, and that's AgOH. So silver hydroxide. The first thing I'm going to do is I'm going to calculate how much silver hydroxide weighs, because I want to get the molar mass. So Ag, we have one of those, and each one of them weighs, where is my periodic table? Let me put this on pause so I can, well actually, I think I've got it written right down here. There we go. There it is. 107.87. And we have 1 oxygen, 16.00, 1 hydrogen, 1.01. Get my total. My total is going to be 124.88 grams per mole. Grams per mole. Now I'm ready to do my calculation. I'm going to start with the percent of Ag, which is silver, first. So that's going to be equal to the part, so the amount of silver, which was 107.87, divided by the whole, 124.88 times 100. You put that in the calculator, and you're going to get 86.38% of silver. Now I'm ready for my oxygen. Again, I made this kind of small, so I'm going to try to squeeze it in over here. So percent of oxygen is going to be equal to 16.00 over my total, 124.88 times 100. And that's going to give me a percent for oxygen of 12.81%. I think I'll put boxes around these so they stand out a little better and so it looks pretty. Last one is hydrogen. So percent of hydrogen is equal to, I only had one of them, so the part was 1.01 divided by my total, 124.88 times 100, and that's going to give you a percent for hydrogen of 0.8. Let's make that an 8. Sometimes I just can't write. 0.81% hydrogen. And I'll put a box around that so that it's easy to see. There we go. All right, the next question, we're going to calculate the percent of nitrogen only in sodium nitrate. So the formula for sodium nitrate is NaNO3. So the first thing we're going to need to do is find out what is the total amount of the weight for that compound, so the molar mass. So I've got sodium. We have one of them. And each one is equal to 22.99. I've got nitrogen. I have one of them. The one is going to weigh 14.01. And then for oxygen, there are 3. Each one is 16.00. So when you total all of this up and multiply them out, the molar mass is going to be 85.00 grams per mole. Grams per mole. Now the only one I need to calculate is the nitrogen. So the percent of nitrogen is going to be equal to the total amount of nitrogen, which was 14.01, divided by the whole, the molar mass, 85.00 times 100. Put that in the calculator, and what do you get? You get 16.48% nitrogen. Put a box around it. There we go. Let's try another one. Again, this one I didn't give you very much space, so I'm going to kind of just make it as big as I possibly can. Calculate the percent composition of the compound C2H5NO. Well, that's a pretty big compound, and we're going to have lots of things to calculate. So I've got carbon, and I have 2 of them. I have hydrogen, 5 of them. I've got nitrogen, 1. And I have oxygen, 1. So carbon, each one is going to weigh 12 point... Oh, carbon. You'd think I'd have this memorized by now. Carbon is 12.01. Hydrogen is 1.01. Nitrogen is 14.01. And oxygen is 16. So we're going to multiply all these out and then finally add them together. And your total for the compound should be a whopping 59.08 grams per mole. All right, so now we got to calculate the percent of all these things. Here's carbon percent. The amount of carbon is going to be 2 times 12.01. So that's going to be 24.02. That's the total amount of carbon, divided by the total weight of the compound, 59.08 times 100. Put it in the calculator, and you're going to get 40.66%. Let's do hydrogen next. Total amount of hydrogen, the 5 times 1.01, total amount of hydrogen is going to be 5.05, divided by 59.08 times 100 is going to give you 8.55% of hydrogen. Now I'm ready for nitrogen. Total amount of nitrogen, we only had 1, so that's 14.01, divided by my total, my molar mass, 59.08 times 100, and that will give me, whoops, that's a 100. That will give me for nitrogen 23.71%. And the last one is oxygen. Percent of oxygen is going to be equal to, we only had 1 of them, so 16.00 divided by the total times 100 equals 27.08%. I'm going to put a box around each of these so we can find the answers. Make it pretty. And there's your answer for that question. Now, this one's a little different. How many grams of iron can be recovered from 450.0 grams of Fe3NO3 So first thing I'm going to do is I'm going to calculate what is the weight of Fe3NO2. And I'm going to start way over here so I have lots of room. So I've got iron, I have nitrogen, I have oxygen. Iron, I only have 1. Nitrogen, I'm going to have 2 because we've got a 2 outside of that parentheses. For oxygen, I'm going to have 6 because 2 times 3 is 6. So iron weighs, grab my weight of iron here, 55.85. Nitrogen is going to be 14.01, and oxygen is 16. We multiply these all out and then add them together, and your total for the compound should be 179.87 grams per mole. All right, now I'm ready to do some calculating here. Now, we only need to know iron, because it says how many grams of iron can be recovered. So I have to figure out what is the percent of iron. That's the only one I need to figure out. So the percent of Fe is going to be equal to the amount of Fe, which was just one of them, so 55.85, divided by the total, 179.87 times 100, is going to be equal to 31.05%. So this compound is 31.05% iron. If I want to find out how many grams that would be, I'm going to multiply the percent by the total weight. So in order to do that, I need to convert this out of percent and turn it into a decimal. So that is going to equal 0.3105. So now I just take my mass, 450.01, multiply it by 0.3105, and I'm going to get 139.7 grams of Fe, and that is my total amount. So this is how percent composition would be used in chemistry. You'd actually use it to find out how much of a certain element you can recover from a product, or you can also determine how much of a certain element is going to be needed to make a certain product. Well, that was it. That was 17 minutes worth of percent composition. This should be enough to give you a good start on information to be able to allow you to do the other questions that you'll now have to work out. See you later. Bye.